doing, and it was really asking the question, if we were to build an area that was lost, that's not a reef anymore but should be a reef, how would we do that best? And why haven't previous approaches worked? So bringing structure back into the ocean in places where that structure has been lost, because it's structure equals habitat, right? So sometimes I like the metaphor of maybe rebuilding a city.
In this episode, I'm talking with Dr. Ulrike Pfreundt, a marine scientist who's co-CEO and co-founder of Reefs. They are using 3D printed clay modules to regenerate coral reefs. Ulrike, thank you so much for joining us this morning.
I'm glad to be here.
And I'm so interested, your company name is RRREEFS. And I remember asking you, exactly how do I pronounce that? So you're saying that typically it's just reefs, but there could be another way to pronounce it?
Yeah, obviously, if we just say reefs, it doesn't really account for the 3 R's, which we put there so deliberately. So in Spanish-speaking countries that we work in, they like to say reefs, which obviously sounds much better.
It does. So what is the meaning of the 3 R's?
They stand for rethinking, rebuilding, and regenerating, and really describe our approach. We found that we needed a new way of thinking about coral reef regeneration, or the regeneration of ecosystems in general. And it also stands for one of our values, curiosity, to always keep rethinking our approach and to always keep learning. Then the rebuilding stands for actually going out there and rebuilding that habitat that is lost in a lot of these places that we work in, that then leads to a natural regeneration of the coral reef.
That is great. What I read quickly your corporate values. Can you just say what they were? I thought they were simple and really clear.
Oh, that's good to hear. So curiosity is certainly one of them. I just explained that. Then it's respect for people, but also for nature. So really for all living beings. Everything that we do has to serve this value. That includes the work with the communities that we do, trying to give as much agency as we can to the people on the ground that depend on these ecosystems. And whom we really want to serve. Then it's passion, that everything we do, we keep doing it out of passion. We are all in this company for the purpose, right? So that's a really important part of it. And then the third one is transparency. We embrace a no bullshit philosophy, and we found this very important for us because in this space, which is a very new space, sometimes there can be claims that are just a bit too much, that are maybe not based on scientific facts. And we really want to try and not focus on a marketing that tries to promise something that we can't keep. So really transparent about the process, where we can't be, where we're currently not yet, where we're going, what we can currently achieve and what we can't.
Your mission on its surface sounds modest. Right? The mission for Reefs is to restore, I think, 1% of coastal coral reefs by 2034. And 1% doesn't sound like a big, hairy, audacious goal. But my bet is in actuality, it translates to something pretty huge. So can you talk about that?
And it's interesting that you say that, because I do hear from especially scientists, mostly you can't put that there. It's too much. How are you ever going to reach that? So the exact opposite of what your impression was. And I think here it's important to really differentiate what we mean by that. And I'm fully aware that we have to maybe explain that statement better. And this really comes from, if you look at all the kilometers of coastline in tropical regions that depend on coral reefs for the protection of their coast from erosion. So natural coral reefs out there take up the wave energy, they reduce the wave height, and they protect coastlines from storms, from very, very aggressive wave action that can erode away the coast, take away the sand, right? And that's about 70,000 kilometers of coastline that depend on coral reefs for that purpose.
And that's primarily in the sort of central of the equator region. of the
Yeah,
world.
exactly. And most of those 70,000 kilometers are inhabited, of course, as a lot of the population does focus in the tropical regions as well, right?
Good, yeah.
So this aim really came from the thinking that if we can bring back a live coral reef that can serve that purpose of erosion protection as well, along just 1% of those 70,000 kilometers, that's 700 kilometers. But with a thought behind that we regenerate this reef only to an extent where it has that capability again. Let's say on a certain stretch of coastline, maybe you have a vast coral reef that extends over a long flat period, over a long flat land. Maybe we don't have to restore that whole area, right? So maybe it's enough if we say regenerate the structure across a long stretch, 100 or 10 kilometers, but only 50 meters wide. Maybe that's enough to keep that coastal protection.
How is it that climate change and warming temperatures and changing weather impact coral reefs?
So the heat is bad for the live corals are animals. Maybe let's start there at the basics. For a long time, people thought they were rocks. Then they thought they were plants, but they're actually animals. And they have inside their tissue a symbiotic algae. So a tiny organism that can soak up sunlight and produce sugar. Then the algae feeds that sugar to the coral animal.
Yeah.
And the coral gives it a good space to sit, closer to the light, and so on and so forth. A typical symbiosis. But when the water gets too warm, the symbiosis turns into a negative one. And the coral seems to expel these symbionts. In effect, the coral then becomes white because it's those algae that gave the coral the color. And that's what we call bleaching.
Oh, okay.
So if you ever see a reef or an image of a reef that's beautifully white, this is a reef
that's dead.
Shortly before all the corals die. Exactly. Because they will starve. And it's important to understand that intermediate state because there's actually reefs that bleach and then they get their symbionts back when the water gets cooler. So it doesn't have to mean that they die.
So it's not irreversible, in other words.
Exactly. It's absolutely reversible if it only happens for a short period of time. Then it cools back down. In principle, those symbionts can come back and the coral can, regenerate itself. And then after that, the coral tissue starts dying. So the actual animal, the polyp, it's a colony of polyps that makes up.
What's a polyp? What does that mean?
So a polyp is a tiny animal, and I would say it's the smallest unit of the coral animal.
Okay.
And we still call that one coral because it's clonal, and the tissue of all these individual polyps is connected. So it's a colony.
Okay.
But also some would call that the individual.
Okay.
It's a debate, I think. You can,
You're saying you get bleach, the temperature rises over a certain length of time, and so the coral can't sort of regenerate itself. It goes like it's not just a heat wave, it's like changed. And so
longer, exactly.
The symbiosis breaks.
The coral starves in the end, starves to death. The tissue starts degenerating, and then what you have left underneath for a while is the skeleton. So again, maybe a branching coral, maybe a boulder coral. Then what is left looks a bit like a rock. And then that usually overgrows with different types of algae. And once that has happened, the ecosystem has kind of shifted to a state where it can be quite hard for coral to come back, even if the conditions, say, got better again. It can be quite hard for an ecosystem, for a reef that's already in that state to regrow to something that you would want to call a reef again. It's then algae dominated. It's a different type of ecosystem. Those algae are often slimy. They cover all the surface, so it's very hard for anything new to settle on that surface again.
Oh, because they're slimy. That makes sense.
And they just cover the surface, right? And new corals, because they're tiny, as I just explained,
right,
like just about 1 millimeter, they need some sort of, not necessarily a free surface, but a surface that suits them. They can actually settle on other types of algae, like calcareous algae, algae that make limestone that are kind of hard. They can settle on those, on some of them as well, but they can't settle on these types of algae that overgrow the dying reefs.
Your career is one where you started studying sort of molecular biology, and then you focused at the University of Freiburg, and then you focused on marine biology, and then you went up to the ETH, and you started about marine ecosystems. And talk us through that path as a scientist. How did you get fascinated with this question?
I got fascinated with the question of, maybe not a question, I just got fascinated with nature, actually, probably long before I started studying. I was an activist for the rainforest when I was 11. Rainforests were very important for me. I tried to raise money. I was devastated hearing that we're losing. I think by then the comparison was like a football field a minute or something. And I thought, no way. We're losing a football field a minute?
Right. How
big must this forest be? But also, how much are we losing? And the concept of biodiversity was a concept for me already at that age. And I just felt this loss so deeply. And I think that really hasn't ever stopped. But then I wanted to go and try and understand. That's why I studied biology. And I really wanted to understand life from the basics, which led me to genetics and molecular biology. But then in my PhD, I turned to the ocean because I had started diving, and kind of this love for nature started to be focused on the ocean.
Wait, you live in Germany, so how did you start diving? I mean, I don't know that much, but I would think the North Sea's cold.
Yeah, and I haven't even probably been to the North Sea once.
Okay.
Which is probably a loss. I should have been there more. But no, really, sometimes things just happen by chance, right? And I went to this diving and marine biology course in the Mediterranean on the island of Elba.
Did you wave to Napoleon?
Exactly. There's a great marine institute there that had good programs. And then I started volunteering there for years. I was there every summer, in late summer for a month at least. Volunteering and getting my dive education kind of in return. So it was kind of a deal. And I also met one of my co-founders there, Hannah, very early, in 2006.
Wow.
I've known her for so long, and she became a co-founder with Reefs as well. I think that really strengthened that connection to the ocean. And because scientists were hanging out there all the time as well, marine science really became an option for me and something that I wanted to look into, and that I realized then in my PhD that if I'm doing a PhD, it has to be with the ocean. So we combined genetics and marine sciences and started looking really at the smallest part of the ocean food web, the microbes, trying to understand how the microbial networks, how those work in the tropical oceans, who works with whom, who does what, who degrades the substance, who takes up nitrogen from the air and puts that into the ocean. Nitrogen fixers is what they're called. And I stuck with nitrogen fixers for quite a while. And
from studying that and doing your PhD, you then decided to continue those studies with Dr. Stocker and do a postdoc?
Yeah, after my PhD in Freiburg, I went to ETH because Professor Stocker had just moved there from MIT. And he was doing really exciting work with ocean microbes, trying to understand lots of different things. But for example, how something that maybe happens on the small scale can have huge effects on a larger scale because there are so many of them.
But you're now working in coral. So how did you flip? How did your loyalties shift?
The loyalty stayed with the tropical oceans.
Okay, good.
But in 2016-17, there was one of the first big global bleaching events. So coral started dying all over the globe. And at the same time, 2017, I was in Silicon Valley for 2.5 months in a very special type of entrepreneurial boot camp, I would say, that was focused on solutions to climate change and mitigation of climate change effects.
Okay.
And just our analysis on the problem space told us that the survival of coral reefs is one of the most urgent problems that we have to tackle
Mm-hmm.
because the consequences arrive very quickly.
You were still at the ETH. You were still in Dr. Stocker's lab when you did this?
Mm-hmm.
Mm-hmm.
Yeah. And he was amazing because I came back and I was like, Roman, I need to work on corals for like 20% of my time.
Mm-hmm.
I want to go to 80. And he said, no, just stay, just stay full time and do it anyways.
That's great.
Yeah, imagine, right? So I had that incredible freedom to start thinking about something.
Mm-hmm.
And I sometimes miss that now, like this time to just think, and
As a co-CEO or even a CEO, you do not have that time.
no chance. Yeah. And at some point that has to come back because you have to spend some time with what you originally, I think started out with, and what serves you also. But I did that for a while. In 2019, I think, we had an idea there that we started pursuing. And it was really I was asking the question, if we were to build an area that was lost, that's not a reef anymore, but should be a reef, how would we do that best?
Mm-hmm.
And why haven't previous approaches worked?
Mm-hmm.
So bringing structure back into the ocean in places where that structure has been lost, because it's structure equals habitat, right? So sometimes I like the metaphor of maybe rebuilding a city.
So how did you connect with the people in the architecture lab? Did Dr. Stoker already have a good relationship with them? Or you just walked down the hallway and said, I need to build an underwater architecture. Help me figure this out.
I can tell that you know ETH very well because they are actually across the hallway in a way. So the building was next to ours. I was at the Institute for Environmental Engineering.
Mm-hmm.
And then the architecture is just across like alumni lounge and
Exactly.
up on Hungerberg. And there was a previous connection with Benjamin Dillenburger. So Roman put us in contact.
Mm-hmm.
I don't actually remember even all the details, but we applied for a small grant to start studying just surfaces. So the question was just, if we iterate the topology of a surface,
Mm-hmm.
topography, pardon, and then measure water flow of it over that surface, what can we learn, say, about the amplitude or the spacing in between topographical elements?
Mm-hmm.
Is it better if we have like a smooth, like mountain kind of topography, mountain and valley, or is it better to have them squared? What does that do to the flow? So, and they had so they have probably still a great sand printer, so they can print sand, which is not, we couldn't put that in the ocean because the glue would dissolve.
Right, because it's sand.
But it was great for the lab. Yeah, it was a glue for the sand. But it was a great additive manufacturing method where you can layer sand in a 3D printer by the 3D printer essentially ejecting the glue.
Mm-hmm.
And so we made all these structures and we started testing. And at the same time, I met my other co-founder, Marie. And she was at architecture, but in a different group. And she's actually an artist. And she had this fellowship with ETH Library Lab.
Huh.
I still don't fully understand how her project went in there. But they had a good idea about, I think, methods and looking into new methods and then how to keep those methods archived and available for everyone to come. And so she started looking into manufacturing methods with clay while I was working with sand at the time, right?
Mm-hmm.
But we met by chance. She read an article. So ETH News, I'm still so grateful for them publishing a story about what we wanted to do because Marie read that story. And then she asked me for a coffee because she was like, wait, there's another woman at ETH trying to work on coral reefs for regeneration. How can, we're in Switzerland and I'm already here. Like, there can't possibly be a second one. And we're both in Hungerberg. So we met in Alumni Lounge for short coffee, turned into 2.5 hours, I think.
Mm-hmm.
And it was in that our first date, it already became very clear that this was a great fit because she was working on the how like, how do we actually build? What system can I think of that makes it easy to do? This gives us design freedom on the individual module, though. And she came up with a system, like the principles of the system that we're still using today. And then we superimposed kind of the work on surface.
That is great. So it sounds like it sounds almost like the ETH ecosystem itself really helped that serendipity happen, right? Where engineers who were looking at 3D printing met architects who were looking at building surfaces that could deal with water pressures and water flows, that could talk to marine biologists who were interested in polyps and when they did grow and how could you make those baby larvae actually happy enough to settle down. But you, that openness to interdisciplinary cooperation does sound like that was really important to helping pull this all together.
Yeah, and the ETH ecosystem, I think, really, really enabled that from the beginning. Even I remember when I started with Roman's group, the amount of different types of scientists that were and still are in that group was new to me, was great.
Right.
It was also a challenge. Before the genetics group that I worked in Freiburg, everyone had the same knowledge, which was also great because you could come with any problem to anybody and they could help you because they also did RNA genetics, for example.
Right.
But here, you had, there were theoretical mathematicians, physicists, engineers. I think in the beginning we were mainly maybe 3 biologists, so not the majority at all. And it just helped me so much also in my scientific work to get this perspective from somebody that was not a biologist on my problems in biology and how a physicist would look at bacteria, or somebody who does modeling. How would they look at a bacterium?
Right.
It's a system. And this thinking of things as a system made so much sense, and it just made a lot of things so much easier. So I've learned to really embrace multidisciplinary thinking and to get together with people that do and come at things from very different perspectives and from very different knowledge.
Ulrike, thank you so much. The time flew, and it's been a great conversation.
Thank you so much. I feel there's so much more we could talk about, right?
Exactly. So I think you might have answered this question, and because we're going to ask a few questions we ask our guests.
Yeah.
When you were young, what did you want to be when you grew up? So when you're that 11-year-old activist, what did you think you'd be when you were growing up?
The funny thing is, when I was a kid, I think the first thing, but that was probably when I was younger than 10, I wanted to be either an astronaut or queen.
Well,
those were the options.
Because there were so many German queens?
I don't know. Very peculiar. Astronaut or queen, both options I would have been totally happy with.
I could get into that.
But then already in ninth grade, I was, okay, I'm doing a PhD in biology.
Wow. That was focused.
Yeah.
I'm impressed. What are you mentioned curiosity as one of your core values. What are you curious about today? What are you learning about?
I wish I had more time to learn about stuff today than I have, but something that is of immediate interest and very new to me, which is why it makes me curious, is to learn about the financial system and how finding innovative ways of generating financial flows into regenerative, I don't even want to say projects, because projects always sound small and project-based, but how could a new type of economy work that takes nature into account? And a lot of people in meetings that I hang out in are much cleverer thinkers in this respect. And there's a couple of really great initiatives like Nature on the Balance Sheet, for example, trying to find out how can we put nature, both the risks that are associated with the loss of nature on the negative side of a balance sheet of a business, because it's a danger to your supply chain, for example. But also then having a place that if you do something for a particular part of nature, can I activate that positively on my balance sheet because I'm actually investing in the future of my company? And that should be valued somewhere. So that's very interesting, but I wish I had more time to look into it.
Well, you have a financial person on your board, so I'm sure that's always helpful. But I'm a reformed banker. I moved to Zurich originally because I worked at UBS, and figuring out how to reflect what they used to call externalities is really hard, right? We still don't even have it for carbon. And at least we have a shared metric that we actually think about. Tons of
so
carbon.
Much easier, right? Yeah.
And I don't know that we even have that shared metric yet around nature, which is probably the first step.
We don't. And the discussions, maybe this is too much for this podcast, but I think the discussions are now moving away again from actually wanting a shared metric because it is too complex to have one metric.
That makes it hard for finance guys and women. What are you reading? What books are you reading? And they don't have to be serious books, right?
Yeah. Well, I just didn't write. I just read a great novel. I love utopist books, so anything it can be dystopic as well. But one that, and I just finished it, where the city of Berlin becomes overgrown by a new type of kind of aggressive grass.
Oh, that's wild.
It's called Grass.
And who is the author?
If I remember correctly, the name is Bernhard Kegel. And it's great because Berlin gets overgrown with this grass and the city just can't keep up with getting rid of it. And all the streets kind of break up. And in the end, it's a savanna.
Oh,
and
that's
there's this
wild.
biologist. Yeah. That studies the grass and kind of the plant communities that grow on it. And she's living as this outlaw in the city after it's been evacuated. And it's just very interesting.
That sounds
to
fabulous.
fathom what could happen.
That sounds fabulous. And if we were in Zurich and I said, let's meet for a coffee, where would we go? What's your favorite place?
Oh, in Zurich for a coffee, I really like Café Paradiesli. Up in Hottingen. It's a tiny place, very old house, and they have this fantastic garden with a fig tree, and it's just a terrace that's overgrown with plants. It's amazing.
That sounds wonderful. Ulrike, thank you again. That was a great conversation, and I look forward to continuing it and to following where Reefs or Reefs goes.
Thank you, Susan.
I'm Susan Kish, host of the We Are ETH series, which tells the story of the alumni and friends of the ETH Zurich, the Swiss Federal Institute of Technology. ETH regularly ranks amongst the top universities in the world, with cutting-edge research, cutting-edge science, and cutting-edge people. Those are the people who were there, the people who are there, and, of course, the people who will be there. Please subscribe to this podcast as we have conversations with those people and tell their stories. And if you enjoyed today's podcast, give us a good rating on Spotify or Apple or YouTube or whatever platform you listen. And I'd like to close by thanking our producers at ETH Alumni and LE Media, and especially to thank you, our listeners.